Question 16. So, a machine produces cylindrical pipes. The mean of the diameters of the pipes is 8 centimeters. So we want to highlight our number. Mean, like average, is another really important word that comes up all the time. So if you see it, it's probably worth highlighting. And the standard deviation, just like mean, that's a really important one, is 0.04 centimeters. Now, assuming a normal distribution. The second you see normal distribution in your exam, you are going to go straight to your reference sheet. Okay, I have one just over here, and in that bottom right corner, there's a normal distribution section. So just above normal distribution, there's this formula here with Z, and that's what you'd be using if they gave you a Z score, where X is just some score you're looking at, X bar is your mean, and S is then your standard deviation. So you can plug in and solve that equation. Otherwise, normal distribution is looking at this bell curve. So the thing with normal distribution, it's symmetrical. Okay, so the left half is identical to the right half, and each of them is split perfectly in half. Okay. Another really important thing, this line down the center, that's actually showing your mean. Alright, so the average. All the numbers, they are your Z scores. All that really means is how many standard deviations they are away from the mean. Right, so if I had a mean of 20, okay, and I had a standard deviation of 2, then one standard deviation above would be 22, and then 24 and 26, and going backwards is the same idea. So you'd have 20 take away 2, so 18, positive 18, 16, and 14. Okay, so that's how you get what those numbers are. Underneath, we have, I'll leave that mean there, it might be helpful. We have percentages and Z scores. So the first one, we've got 68% of scores sit between -1 and 1 standard deviations. So that is this area here roughly, is going to be your 68% of the data. So most of it, like 70%, a good chunk. Okay. Another really useful thing with each of these percentages, because it's all symmetrical, if you wanted to, say, cut it in half and see what percentage was between 0 and -1, that's just going to be half of 68, so 34%. And that's really how most of these questions end up working. Spoilers. The next one is 95% between -2 and 2. So that's including that area we just covered, going from -2 all the way up to 2. That whole area, all of those scores, is going to add up to be 95%. So pretty much everything. And finally, the last one, we may as well cover it, is 99.7. So pretty much everything. We're always going to miss that 0.3% when we do a normal distribution between -3 and 3. Okay, so you can see that if we color it all in, I'm going to do a really messy job on this one, that there's those little slivers left over, and that's where your 0.3% would be sitting. Right, but this all up is your 99.7%. And again, we could halve it, we could take away chunks, we can do that kind of maths. So if we come back to our question, just over here, we are looking for what percentage of pipes will have a diameter less than 7.96. Now, if you're approaching this question without really thinking about it, you might be completely lost. But because we looked at our normal distribution on the reference sheet, you know that you're always going to be starting with your mean, in this case 8 centimeters, and we're going to be either adding or taking away standard deviations. So to get from 8 centimeters to 7.96, it's less, so you're going to take off 0.04 centimeters. Okay, so that's 7.96, and that is -1 standard deviation. Okay, so if we come back to our little picture, again, I'd be scribbling over all of this in your exam. We are talking about scores that are less than -1. So that blue area, basically, including the little bit beyond -3. Now, there's a ton of ways to figure this out. What I think would be the easiest is to start by realizing it's basically almost that whole left half. And if it was that whole left half, we'd be calling that 50% because it's half of the data. Okay, it's basically 50% except for that chunk there. But luckily, like we were talking about before, that chunk there is really easy to find because it's just half of that 68% from -1 to 1. Half of 68 gives me 34. So what's left over? It's going to be 50%, take away 34%. Just going to leave you with 16%. You can ignore the percents when you do all this maths. It's just 50 take away 34. And that will be our answer, 16%. Lovely. So the next one, we've got the area of the triangle is 250. Now straight away, when you see area of a triangle, and it's actually given us a number as well, we're again going to go straight to our reference sheet. We're talking about triangles, so we are finding trigonometry. Now there's only one formula under trigonometry that starts with an A for area, and that is this one just here. Okay, so we're going to grab that, come back and write it down. So A equals half AB sine C. Okay, so then we've got our picture and it says what is the value of x? So this is what we're actually finding to the nearest whole number. So all you need to do to answer this question is plug in the information that we've got. Okay, to start with, we already know the area, and that's 250. A half is just a half, and we know that we're timesing whenever we have numbers or letters next to each other. Now, picking what is A, B, and C is the main trick to this question. When you use the area rule, this angle C is obviously going to be 44. It's the only angle we've got. So if we're calling that point C, the trick is the side C is always going to be opposite. Okay, the angle is always opposite the side, and that's how we name a triangle. So if that's angle C, the side opposite is going to be side C, which leaves the other two being A and B. The order of those doesn't matter. It could be A or B on either side. If you can figure that out, that we're using that angle, so that means the opposite side is C, it matches up, then you'll get everything right from there. So we've got half times 30 times x times sine of that angle, 44. Okay, this is just equations at this point, has nothing to do with trig, we're just trying to get x on its own. And again, when we have all these timeses, or timesing, right, we want to get rid of times. So to get rid of that, I'm going to divide 250 by everything except for x. So I'm going to divide it by half times 30 times sine of 44. I wouldn't try and do too much mental math. I would just chuck that straight into my calculator, that whole left side there, and that will pop out an answer of 23.99, and it goes on for a bit. And remember, we're finding x. Closest answer there, 24. Lovely. Okay, final last question, question 18. We have an insurance company that offers customers the following discounts based on the basic annual premium for car insurance. Okay, so we have three types. The first discount is a multi-policy discount. So if an owner has more than 2 policies, they get 15% off. Next bonus is a no claim bonus. So if an owner has had at least 5 years without a claim, they get 20% off. And the final was a combined compulsory third party or CTP and comprehensive insurance. So if an owner has both insurances with the company, they get $50 off. Okay, so if a customer is eligible for more than one discount, which I'm assuming we will be, subsequent discounts, which means discounts after the first one, are applied to the already discounted premium. So it's a really tricky way of just saying it's going to be 15% off and then 20% off and then $50 off. Okay, off each answer. The CTP and comprehensive insurance discount is always applied last. Okay, so that's at $50 off, that's going to be our last step. So Jamie has 3 insurance policies. He has combined CTP and comprehensive, and he's used the company for 8 years, never made a claim. The basic annual premium for his car insurance is $870, and we want to know how much he'll need to pay after the discounts. So there's a lot going on, but the maths isn't actually too tricky in this one. You want to start with our $870, and we're going to check what discounts he actually qualifies for. So the first one, does he have more than 2 insurance policies with the company? Yes, he has 3. So he's going to get that 15% discount. So I'm just going to work through it straight away and say we're going to have $870, take away 15%. That should give you $739.5. Another way, if for some reason it's not working, calculate's freaking out, or it's just easier for you to remember, you could always just say 870 times, now if I have 100%, which is 870, and I take away 15%, that's going to leave me with, 85%. And that would get you the same answer. That trick's always going to work. So 100%, take away what you're taking away. So we'll check the next one. So a no claim bonus has to be at least 5 years without a claim. And he's used it for 8 years, never made a claim. So he's going to get an extra 20% off that. So we're going to have 739.5, take away 20%, which should give us 591.6. Again, if you like the other way, you could just say 739.5 times by 80%. Okay. Last thing, he has both insurances with the company, which is a combined CTP and comprehensive, so he gets that one as well. So he's going to have finally 591.6, take away $50. Should be 541.6. Now we want to have a look at our answers, and beautiful, one lines up. And that's it. Multiple choice done.